Yes, hello, my name is Eric Gregg. I formed GM Instruments 25 years ago, and among the products that we've supported in that time is an acoustic Rhinometer, which I'd like to take you through today. The acoustic Rhinometer is an instrument which allows you very quickly and easily to determine the structure of a nose. It measures the internal profile of the nose, and it presents that information in the form of cross-sectional area as a function of distance. So with very little effort, you're able to produce a profile, an internal profile of the nose, to determine where the obstructions are and how severe the obstructions are, and to allow you to compare before and after treatment what has happened inside the nose. The acoustic Rhinometer itself comprises of the transducer box, which I have in front of me here, and a sound tube. The system operates by generating a click sound at the black box here, which travels up an internal tube, past the microphone, and exits the sound tube at the end here through a nose piece, and that is normally applied to the nose when we're making measurements. As the sound travels up the tube and past the microphone and then into the nose, anywhere where there's a change in cross-sectional area produces a reflection back down the sound tube again, which we process in order to give a plot of cross-sectional area as a function of distance. To operate the system, we have software which is attached to running on a PC. I'm going to start up the software now and load the program, and on the screen you'll be able to see that there's an acoustic acquisition button here, which I'll press, which brings up the acquisition screen. And this shows you a plot of cross-sectional area on that axis as a function of distance on the horizontal axis. When we make a measurement, the trace that's produced will be superimposed on the standard nose trace, which you can see on the screen just now. And that gives you an indication of how that particular measurement compares against what is considered by the Standardization Committee to be a typical nose. But perhaps before we get to that point, you would almost certainly want to either open a file that's already been saved, a file that would contain the test results for a previous subject, if you want to do additional testing, or you would start with the new button in order to put in some patient details. But I'm going to open up a previously saved file now to bring it back into the system. So the test results that you'll see on the screen are those that have been obtained in previous visits for a particular person. To make a measurement, we would then go back to the acquisition screen, and the first thing we'd want to do is to calibrate the instrument. Calibration is very straightforward. We have a calibration plug which goes in the end of the sound tube. We click on the calibrate button, and a message will appear on the screen then which says that the A1 acoustic Rhinometer is calibrated. To move forward and make a measurement, we select a nose piece that's appropriately sized for the person that you're testing, and we have two forms of anatomical nose pieces, a large one and a medium one. Now these are handed because they are intended to fit on the outside of the nose comfortably without distorting the nose. If the nostril that you hope to measure is round in shape, then we also have a conical nose piece which can again sit on the outside of the nose in order to make a seal and allow the measurement to be made. So I'm going to take first of all the left side. The left sound tube nose piece is coloured blue. On the acquisition screen I have already selected left, and I'm now ready to make a measurement. The instruction to the subject is very simply that we ask them to take a breath in and hold their breath while we're making the measurement. But first of all we need to apply the nose piece, and normally I would suggest that you help the subject position it so that it looks as if it's sealing without distorting the nose too much. Normally I would then ask them to take a couple of breaths in and out through the nose so that they can feel whether there's any leakage there. And typically if there is leakage, the subject will be able to feel that and tell you, and then you could perhaps reposition the nose piece. But once you've got it in the right position and the subject is supporting the sound tube appropriately, the instruction to them would be to continue to mouth breathe while this process is going on, and when you're ready to make a measurement, ask them to take a breath in and hold their breath. So take a breath in through the mouth, hold their breath, and then the measurement can be taken. So I'm now ready to make a measurement. Take a deep breath in, please. And that's the measurement. That's now complete. We've taken in 4 complete cycles, and the results are presented on the screen. Again, with vertical axis is cross-sectional area, horizontal axis is distance into the nose. So you'll be able to see on the screen now that my trace is quite obstructed, showing quite an obstructed nose. The major obstruction comes in at roughly 2.5 centimetres, the head of the first turbinate almost certainly, and then opens out. So the trace goes down when it meets an obstruction until it reaches the maximum point of the instruction, which is what we call min 1. It then opens out again, and then typically will at least one other minimum decrease and increase again. The information at the bottom of the screen allows you to determine how severe the obstruction is for min 1 and min 2, and also to measure the volume between 0, starting point of the nose, and 5 centimetres into the nose. That was a measurement for the left side. If we want to do the right side as well, then we would click the acquisition button, select the right nose, and if appropriate, change the nose piece over. Apply the nose piece to the nose with the pointed section of the anatomical nose piece in towards the middle. Ask them to check for leakage, and if that's okay, ask them to take a deep breath in and hold it, and then measure. And that's us now got another 4 cycles recorded on the system. So to the previous results that are already on the computer, we now have a left side result and a right side result. I can mark the both of them, right click and create a combined test which shows us the left and right superimposed. Underneath the graphs we include now a lot of other information relating to both of the measurements, and also there's a calculation of percentage difference between the left and the right side. Having done this test, we may want to compare this test with a previous one. So if we go back to our list of tests and select an earlier one, that's very consistent, that's a left and a right there, and we want to compare it with the one that we've just done. We mark them both, right click, create an analysis test, and the new test result can then be displayed on the screen with the baseline left and right in this quadrant, the comparison left and right in this quadrant, and then the two of them superimposed in different line styles. So you can very clearly see the difference that the decongestant has made to the two test results. And as before, in comparing those two test results, at the bottom there we're able to give you percentage change in a number of different parameters such as volume slices and distances into the nose and minimums. We were able to give you all of that additional data. In terms of performing an acoustic rhinometry test, the fundamentally important things are that you avoid distortion as much as possible and you avoid leakage as much as possible, which is why positioning the nose piece is a very, very important part of it. The reason we ask the subject to breathe in and out through the nose once the tube's connected to check for leakage is just that we want to minimise leakage. You have a visual line of sight to the nose to see whether it's being distorted or not, and those two parameters together are fundamental to getting good results. The other thing that is very important is that you ask the person to hold their breath while you're making the measurement. Measurement takes about 4 seconds, but if they can hold their breath for that time period, then the structures at the back of the nose remain static, and don't create any fluttering or any fluctuations in pressure, and therefore produce more consistent results. Ideally, the traces on the screen should be very tight. There are 4 clicks typically, although you can alter it to a higher number or a lower number, but typically we present 4 clicks, do 4 calculations, take the average of those, and that gives us our parameters and our values. If there's a lot of background noise, that will make those 4 traces a bit more diverse, although we still take the average of them, but better accuracy is achieved if we can have a quiet environment and produce traces that are tight, traces that are very close together. So ideally, in terms of preparing the patient, you look for a quiet environment. You need a little bit of cooperation from the subject so that they don't, so that they're able to perhaps hold their breath when you ask them to, and to check for leakage when you ask them to. They should also be in a stable environment for 10 to 15 minutes before you make the measurements, and ideally you should have a protocol which determines whether you're going to decongest before the measurement, or whether if you're doing an allergen challenge, you may perhaps do a series of tests to decongest, and then a follow-on series at 5-10 minute intervals or whatever, to see the effect of the decongestant and see how it affects the front end and then further back. But it depends on the kind of work you're doing. If your interest is surgical, then certainly you would decongest at the beginning and then make follow-on measurements looking at the basic structure of the nose. So an acoustic rhinometer is a simple instrument to use. It's very quick to use. It gives you information on the internal structure of the nose and allows you to measure changes that occur because of either surgery or decongesting or an allergen response challenge. It's also useful in terms of doing sleep studies to see how effective the nose is as an airway.